गुड आफ्टरनून स्टूडेंट्स। तो लास्ट लेक्चर में थोड़ा रिवीजन हम कर लेते हैं क्योंकि एक हफ्ते का गैप हो गया बीच में। सो लास्ट वीक में हम पढ़ा था अबाउट द गैलोइज फील्ड. सो गैलोइज फील्ड is a finite group of ring fields, right? And in this the number of elements will be finite, and initially we have to use the prime numbers inside the Galois field. So it is indicated as gf p to the power n, and the range will be vary from 0 to n minus 1. So if it is p, so it will be indicated as 0 to p minus 1. So it is called as Galois field in terms of the prime numbers. So there are two operations associated with the Galois field. The first one is addition and the second one is the multiplication. So for the addition, the term is simple. If there are two numbers only, so in terms of the binary, they are 0 and 1. So whatever the addition you have performed, you have to perform only the XOR one, and in the multiplication, you have to perform the AND operation. And if you are supplying the digit values, suppose my prime number range is 5, so we have 0 to p minus 1 means 0, 1, 2, 3, 4, 4 numbers, including 0. And these are the corresponding addition and the multiplication operation. So whenever the output is going out of range, you have to apply the mod operation in order to do the reduction. In such a way, you have to find out the additive inverses and the multiplicative inverses. These are the formulas. Now there are one drawback associated with the prime numbers of Galois field, because in the computer we have to store all the things in the terms of bits and bytes. So if you are taking 2 to the power n term, then in the 2 to the power n, what will be the maximum prime number? Suppose if the n value is 4, then what will be the range? The range will be 0 to 2 to the power 4 minus 1, that is 0 to 15. So under this range, that is 0 to 15, the largest prime number is 13. So if we talk about ZP, means Galois field, under the prime operation, prime number, so 13 will be there. So what will be the prime number range? 0 to 12. So in that So that is one of the drawback associated with the Galois field associated with the prime number. So therefore for the efficient storage of the bits inside our memory, computer memory, we have to use 2 to the power n Galois field. So after the finishing of Galois field, we learned about the polynomials. So what is the polynomials? Operations are addition and the multiplication, and the polynomials is expressed in terms of the terms as well as the coefficient. So the term is indicated by xi, and it is comes under the Galois field 2 to the power n, and the coefficient ai will be associated with only two numbers, that is 0 and 1, and because these are only two numbers, so it will be concerned with the Galois field 2, where n equal to 1. So these are one of the example, that is 8-bit word we have in the terms of polynomial we have to represent. So the meaning of 8-bit word is we have highest power, that is 7. So from 0, 1, 2, 3, 4, 5, 7, we have to align all of the bits. So 1, 0, 0, 1, 1, 0, 0, 1. So after the alignment of this coefficient, so whenever the 1 is present, we have to align the associated power values of the term, like 1 into x to the power 7, 0 into x to the power 6, 0 into x to the power 5, and so on. So whenever there is a 0 associated values, we have to cancel out there. We have to fetch only the 1 multiplied values only, like x7, x4, x3, and x0. So that will be your answer. Now this is one of the another example, the same example. So there are two operations associated with the polynomials, the addition and the multiplication. There is no problem is occurring over the addition operation, because if you add the polynomials will be cancelled out, but otherwise it will not be overcome the out of bound power values. So if the highest power is 5, then in the outcome the highest power will be 5 only. But in the multiplication the case is different. In the multiplication, whatever the polynomial values you have multiplied, it may be possible your outcome, the power associated with the outcome is exceeding the highest degree. In this way, you have to perform the modulo operation. So modulo in terms of the reduction, you have to use the irreducible polynomial. So the same example I've already depicted. That is, there is a polynomial P1 and this is a polynomial P2. So we have to multiply these two polynomials in the Galois way. 2 to the power 8 means the highest power is 7. And addition means you have to perform the XOR operation. So one thing you have to remember in the polynomial operation, all of the addition and the subtraction signs will be treated as same, because we are performing the XOR one now, that's why. And what will be the outcome? The outcome is simple. You have to perform the addition, just cancel out the common terms and take the uncommon terms. That will be your answer. So there will be no need of reduction because we are performing the addition operation. But in the multiplication, we have performed the reduction operation also. So this is the P1 and P2. We have to perform the multiplication operation between the two in the Galois wheel 2 to the power 8, and this is the irreducible polynomial. It is given to you in the question. So what we have to do in this multiplication, we have to multiply the each value of polynomial P1, means each term of polynomial P1, to the whole value of the P2. Like x5 will be multiplied with the x7, x4 plus x3, x2 and x and so on. After the multiplication, whatever the common values you have occurred, you have to cancel that term, and the answer will be written over the uncommon terms like x12, x7 and x square. So in the answer you can see over there the 12 power is exceeding over the maximum power limit, that is 7, because we are talking about GF 2 to the power 8, so maximum power will be 7 now, and it is exceeding, so you have to perform the modulo operation. Modulo operation with irreducible polynomial that is given to you in the question. So what is the method? You have to perform the simple division type of operation. So after the division, whatever the remainder you have, that will be your answer. That is x5, x cube, x square plus x plus 1. तो ये सारी चीजें हमने पिछले लेक्चर में पढ़ी. अब हम आगे चलते हैं. So in the continuation of the polynomial, we will explain now the multiplicative inverses. So how to find the multiplicative inverse when the operation we have to perform in the terms of the polynomial. So the same Euclidean extended Euclidean algorithm we have to apply over there. So what the extended Euclidean algorithm says. So in short मैं आपको बता रही हूँ, पूरा algorithm नहीं लिखूंगी. You have to the algorithm. While condition of while R2 is greater than 0. Sorry. So when this condition is terminated, you have to check out the value of R1. So if the R1 value is equal to 1, then multiplicative inverse value with the value of T1 as. If R1 value is not 1, then you can print the multiplicative inverse is not possible. This is a short form of extended Euclidean algorithm for the understanding and the revision point of view. So we directly jump to the example for the better understanding, otherwise theory में कुछ रखा नहीं है. So in GF 2 to the power 4 means the highest power is 3. Find the multiplicative inverse of x square plus 1 mod x4 plus x plus 1. Okay, so it will be termed as a P1, it will be termed as a P2. So in the extended regulated algorithm, we have to use some variables like S, T, T1. So in this case, we will not consider S values, we will consider only the T values because we are concentrated only the finding of multiplicative inverses, not the finding of its values of S1, S2 or T1, T2. So Q, R1, R2 quotient, R1, R2 remainder, and T1, T2 and T. We have to find the value of T1, T2 because the value of T1 will decide the multiplicative inverse. Now the same procedure we have to follow. Whatever the higher value of the power in the polynomial we have, it will become the value of R1. तो इन दोनों में से बड़ा कौन है? x4 to the power x to the power 4 plus x plus 1. So x to the power 4 plus x plus 1, the R2 will become x square plus 1. The value of T1 will be 0 by default and value of T2 is 1. So the first operation is, in order to find out the value of Q and T, we have to divide x square plus 1 and this one. So manual method ही use करना है, कोई और method नहीं है इसका. So it will be x to the power 4 and x square, it will be cancel out. So x square plus x plus 1 plus 1 oh, so x square plus 1 only. Common terms will be cancelled and the remainder is x. So the remainder is x, your quotient is x square plus 1. Now we have to find out the value of t. So what is the value of t? Value of t will be t1 minus q into t2. What is the value of t1? That is 0. Value of q is x square plus 1 and t2 is 1. So it will be termed as minus x square plus 1. So as I told you, in the polynomial, minus and the plus operator will be treated as same because in actual we have to perform the XOR operation. So XOR operation में अगर आप दो values को, जैसे suppose -1 है और दूसरा -1 है, तो माइनस अगर कॉमन लो तो +1 आता है. अगर XOR परफॉर्म कर रहे हो इन दोनों के बीच में तो ये कैंसिल हो जाएंगे ऑटोमेटिकली. ठीक है, सो माइनस एंड द एडिशन प्लस ऑपरेशन विल बी ट्रीटेड एज सेम. तो अभी के लिए मैं यहाँ पे माइनस लिख देती हूँ, कोई फर्क नहीं पड़ता, आप प्लस भी लिख सकते हो. Now shift, the shifting will be x square plus 1, here x, here 1 and x square plus 1. Now again perform the same operation, x square plus 1, so it will be x square, cancel out and 1, so the remainder is 1 over there and the quotient is x. Now what will be the value of t? The value of t will be t1 minus t2 into q. ठीक है, तो मैं ये माइनस माइनस साइन हटा दे रही हूँ, तो इट विल बी x cube plus x. So 1 plus x cube. Now the shifting will be x and 1. Here it will be x square plus 1. If you want, you can put the minus sign, otherwise it is not mandatory. And x cube plus x plus 1. Again, you have to perform the same one. So 1 and x it will be 0. So the remainder will be 0 over there, and the quotient is x. What will be the value of t? The value of t will be, calculate कर देती हूँ, t1 minus q into t2. So when you simplify it, it will be calculated as minus x4. Now shifting. So shifting will be 1 and 0, and the t1 will be x cube plus x plus 1, and it will be minus x4. So now the condition will be terminated because my R2 is equal to 0. So when my R2 is equal to 0, my condition will be terminated, and we have to check out the value of R1. So if the value of R1 is equal to 1, then we can say the value of T1 will be the multiplicative inverse. So in this case, yes, my value of R1 will be equal to 1. So we can say the multiplicative inverse. The answer is x cube plus x plus 1. So it is very, very simple, and it is similar to the previous approach. But in terms, in place of the digit, you have to play with the polynomials, means terms. Now question is to you. In the Galois field, gf2 to the power 8, you have to find out the multiplicative inverse of x to the power 5 mod x8 plus x4 plus x cube plus x plus 1. ये cube है. Find out and tell me the answer. जब तक मैं पानी पी लेती हूँ. Yes, Pulkit, your answer is correct. So I will leave this question for you as a homework. So जिनका नहीं हुआ है वो कर लें, और जिनको अभी करने का मन नहीं है वो बाद में कर लें, जैसे भी इच्छा हो आप लोग की. चलो. So we will move toward the different method of multiplication. तो अभी तक हम मैनुअल मल्टीप्लिकेशन मेथड परफॉर्म कर रहे थे. In the manual method, what we have done, suppose if there is a polynomial x cube plus 1, and there is another polynomial like x5 plus x4 plus 1. So we have to multiply each term of the polynomial with the whole term of the polynomial of P2. Like x cube will be multiplied with x5, x4 plus 1, and the second term of polynomial P1 will be multiplied with x5 plus x4 plus 1. So it is very time consuming process, and chances of mistakes is very high. So that's why there is a different method for the in order to perform the multiplication between the polynomials. So in this method, suppose we have polynomial P1 with the value of x to the power 5 x squared plus x, and the second polynomial is x to the power 7 x4 x cube plus x squared plus x. Because we are performing the multiplication, so it may be chance the highest power will get multiplied and it will exceed to the highest power limit. So This is the highest power in P1, that is x5. This is the highest power in P2, that is 7. So in the multiplication, the powers will get addited. So 7 plus 5 equal to 12. And 12 is greater than 7 because the maximum power is 7 over there. So we need reduction. So in the reduction, irreducible polynomial will be given to you in the question, that is x to the power 8, x to the 4, x cubed plus x plus 1. So in the different method of multiplication, you have to just start with one logic, that is in the polynomial P2, the maximum power is 7. In the polynomial P1, the maximum power is 5. So in the traditional method, we multiply each term of the polynomial with the second polynomial in a group. So highest power in the P1 is 5. Suppose if we perform the multiplication polynomial P1 first time, this x is divided into 5 parts, that is x, 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 and x, right? And this whole term after the multiplication will make x to the power 5. So we will divide this x to the power 5, that is highest power in P1, into the multiple individual parts. And we have the multiply all of the polynomial single values one by one to the P2 polynomial. So first time x will be multiplied. Second time, this is the first time. Second time, this x, this one x will multiplied with the first term. Okay. Third time, this x, the third polynomial, single polynomial, will be multiplied by the second term. Fourth time, the fourth polynomial, that is this one, will be multiplied by the third term, third computer term. And in the fifth one, the last polynomial term will be multiplied by the previous computed fourth term. So in this way, when all of the terms are combined, then we can say it is the outcome of x to the power 5, x7, x4, x cube plus x square plus x. ठीक है, ऐसा हम कह सकते हैं. And also because this is the highest term, and what are the remaining polynomial terms in the P1, that is x square and x, that is already computed in all of the 5 phases, right? X square is this one and this one. Okay, what is x? X will be this one. भाई सेकेंड वाले को जब हम इस वाले से मल्टीप्लाई करेंगे तो ये ऑटोमेटिक मुझे एक्स स्क्वायर दे देगा ना. एक्स स्क्वायर x7 plus x4 plus x cube plus x square plus x. So we do not need to multiply each of the terms separately to the polynomial P2. We have to just pick the highest power, divide it into the single values, and multiply all the values one by one with all of the polynomial terms in the P2 and find out the answer in a unique way, in a one-phase manner. So that is the theme of the different method of multiplication. Now see this example. So in this method, we have to make a table. The first table will be termed as the powers. The second will be termed as the operations. The third will be depicted as new result. And the last one is, इसको मैं थोड़ा बड़ा लिखती हूँ. And the last one is reduction. Because in the last power, it will outcome x to the power 12. So if it is the case, then you have to perform the reduction. ठीक. Our highest power मेरी कितनी है? X to the power 7. So all of the terms related to x to the power 8, x to the power 9, x to the power 10, x to the power 11 will need reduction. So what are the powers? So this first phase will be termed as x to the power 0 because we are talking about 0, 1, 2, 3 and 4 powers. 4 and 5, sorry, including the constant one. So if we include the constant, we have to align one more phase over there. So x to the power 0 is the first term. ये इसके पहले का भी टर्म होगा, सपोज एक -1 का टर्म है, ठीक है। x to the power 1 मेरा 1 से है, x to the power 2 मेरा सेकेंड फेज से है, x to the power 3 मेरा थर्ड फेज से है, ये x to the power 4 है, and it will be x to the power 5. So x to the power 0 and multiply it with the polynomial p2, x to the power 1 multiplied with polynomial p2, x to the power 2, इसी तरह के सारे होंगे, ज्यादा बोलूंगी मुझे खांसी आ रही है। So the first operation, because we are only multiplying with the constant value, so it will be treated as 1. ठीक है, and what will be the result? Because 1 will be multiplied with p2. What is the value of p2? Value of p2 is x to the power 7. यही तो है, just find the value of p2. So same result will be copied over there. So there is a need of deduction. Check from the new result. The power is not exceeding, so there is no need of deduction. Now the second operation is x to the power 1 and p2. So x to the power 1 means x multiplied by x to the power 7, x to the power 4, x cubed plus x squared plus x. So when we multiplied this value, so the answer is x to the power 1, p2 will give you the answer x to the power 8, x to the power 4, sorry 5, x to the power 4, x cube and x squared. Because highest power is only 7, so we need a reduction over there. ठीक है, exceeding power. You need reduction. So there is a need of reduction, so we have to put down there yes. And for the reduction, we have to use the irreducible polynomial, because we are performing only the addition and the addition operation or the subtraction operation in terms of the XOR one. So just perform the XOR operation between the two polynomials. So this one is your outcome. And what is your irreducible polynomial given to you in the question? That is x to the power 8, x to the power 4, x cube, x plus 1. Now cancel the common terms. So x8 is common, x4 is common, x3 is common. So the answer will be x5, x squared plus x plus 1. So that will be your answer for the second phase. Now again x squared multiplied with the p2, but here there is a one thing you have to make sure, because in the concept we have used that in each phase we have to multiply with the single value of x powers to the polynomial p2, and this x powers will be multiplied by the result of the previous one. तभी यहाँ पे लिखा है ना x into the result of the phase 1, and there is result of the phase 2, result of the phase 3. So यहाँ पे x to the power 2 का मतलब सीधे x to the power 2 से multiply करने का नहीं है, that is only x. And what is the result? Previous result is x to the power 5, x squared plus x plus 1. Now multiply, that is x6, x cube, x squared plus x. So check there is a need of deduction or not. There is no need of deduction. So the answer is no over there. Now again multiply with the new value. The new result value, that is x cube plus x square plus x, that is x7, x4, x cube and x square. So there is a need of reduction? No. Again the x will be multiplied with the previous result value, that is that one. So x to the power 7, x to the power 4, x cube and x square. So it can be seen that after multiplying these two polynomials value, you will get the higher power result, that is x to the power 5, x to the power 5, sorry, x to the power 8, x to the power 5, x to the power 4 and x cube. And for the reduction, you have to perform the XOR operation with the irreducible polynomial. Cancel the common terms. So the answer is x5, x plus 1. There was reduction, yes. Now the last will be x to the power 5 plus x plus 1 multiply x6, x square plus x. So there is a need of reduction? No. Now, how to find out the answer, the final answer? Simple, very simple. You have to just figure out those values that they are mentioned in your first polynomial. So what is the polynomial value? What is the term? Sorry. What is the value in the first polynomial term? First polynomial is x to the power 5, x square plus x. तो check out where is x to the power 5, क्या है मेरा polynomial? x to the power 5, x square plus x. तो टिक करो यहाँ पे, x to the power 5 मैंने यहाँ कैलकुलेट किया है, x square कहाँ कैलकुलेट किया है? यहाँ पे, x कहाँ पे कैलकुलेट किया है? यहाँ पे, ठीक है। और मेरे को वही सारी वैल्यूज लेनी है, उन सबको एडिशन करा देना है। क्यों एडिशन क्यों करा रहे हैं? क्योंकि यहाँ पे हम क्या कर रहे हैं? एडिशन ही परफॉर्म कर रहे हैं ना। So x to the power 5 का आंसर कितना है? That is x6, x square plus x. XOR operation with x square, इसका है x6, x3, x square plus x. और x का है x5 plus x square plus x plus 1. Cancel the common term. स्क्वायर भी गया, x भी गया, और क्या 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 गया? x क्यूब भी नहीं, ठीक है। तो ये आ जाएगा मेरा x5 plus x cube plus x square plus x plus 1. That will be your answer. So आंसर फाइंड करना, मैच करना प्रीवियस वाले की इक्वल ही होगा। So that is the different method in order to solve the multiplication of polynomial. तो इस मेथड में किसी को डाउट कि मैं दोबारा एक्सप्लेन करूं इसको? नहीं तो मैं आगे प्रोसीड करूं। It is very simple, just you have to figure out the highest power. ठीक है, हाईएस्ट पावर मेरे x to the power 5 है, तो मेरे को 5 टाइम्स x से मल्टीप्लाई करना पड़ेगा। ठीक है, अब क्योंकि मेरे पॉलिनोमियल में जो कांस्टेंट भी रिजल्ट होता है, लाइक x to the power 0, x to the power 0 का भी टर्म होता है ना, सो दैट्स व्हाई हमने यहाँ पे इंक्लूड किया x to the power 0, ये हमें करना पड़ेगा। ठीक है, तो हम टोटल 5 टाइम्स मल्टीप्लाई करेंगे, सॉरी 6 टाइम्स मल्टीप्लाई करेंगे। ठीक है, 0 को अगर हम इंक्लूड कर रहे हैं, सो x to the power 0, x to the power 1, x to the power 2, x to the power 3, x to the power 4, x to the power 5। ठीक है, सो मल्टीप्लाई करने के बाद मेरे को वो सारे आंसर्स निकालने हैं जो मेरे फर्स्ट पॉलिनोमियल में है। ठीक, फर्स्ट पॉलिनोमियल में मेरे क्या क्या टर्म थे, दैट इज x टू द पावर 5, x स्क्वायर एंड x, वो सारे योर आंसर, बस इतना ही करना है. And also in order to get the new result you have to perform the reductions also, you have to check for each reduction. अगर आपका वैल्यू एक्सीड कर रहा है हाईएस्ट पावर से दैट इज 7, तो आपको रिडक्शन करना है, अदरवाइज देयर विल बी नो नीड ऑफ रिडक्शन. इसमें अभी तक किसी को डाउट, मैं आगे बढ़ूं? यस और नो? Just write in the chat box such that I can know about and understanding the concept of the today's lecture. ओके, लगता है सब सो गए हैं, मैं आगे ही बढ़ जाती हूँ. सो सेम मल्टीप्लिकेशन हम परफॉर्म करेंगे इन द बाइनरी फॉर्मेट आल्सो. ये सारे न्यूमेरिकल्स आपके एग्जाम में बहुत आते हैं, इसलिए मुझे कराने पड़ रहे हैं. बाइनरी फॉर्मेट मल्टीप्लिकेशन. सो सेम P1 P2 लेंगे बट इन द फॉर्म ऑफ द बाइनरी. तो 0 0 1 0 0 चेक करना ये सही है, प्रीवियस पॉलिनोमियल जो मैंने लिए थे. और P2 में मेरा 1 0 0 और इरेड्यूसिबल पॉलिनोमियल है 1 3 times 0 1 1 0 and 1 0. So same table you have to draw over there, that is power. Second one is shift left operation. And the third one is reduction. ठीक है, reduction and answer. तो मुझे पता है कि मेरा x to the power 5 मेरा हाईएस्ट टर्म था इन P1. तो मैं x to the power 0 से स्टार्ट करूंगी, x to the power 0, x to the power 1, x to the power 3, x to the power 4 and 5 and multiplied with P2. So the first option is only the constant one. So the same P2 will be the answer and there is no need of reduction. वो हम चेक करेंगे कि रिडक्शन का जरूरत है कि नहीं. पहले तो हम आंसर डायरेक्ट लिख देंगे, that is 1 0 0 4 times 1 and 0. अब now पिछले वाले पॉलिनोमियल में मुझे पता चल रहा था कि कहाँ मुझे रिडक्शन का जरूरत है after analysis of the highest power, but in this case how to find out the highest power? So the logic is you have to check the number, you have to check if there is one occurring in the first phase or not. If there is a one occurring, then there is a need of reduction, otherwise not. So in this case, after getting the result, the first value is 1. It indicates you have to perform the reduction with irreducible polynomial. So कैसे डिडक्शन करना है, ये डिडक्शन का आंसर मेरे इस वाले फेज में जाएगा. ठीक है, यहीं पे नहीं जाएगा, यहाँ पे खत्म हो गया, ये फर्स्ट फेज मेरा खत्म हो गया. So starting from the second phase, we have to perform the shift left operation of this value. So what is the shift left? That is 0 0. 4 times 1 0 and लास्ट में मेरा 0 आ जाएगा. Because in the previous case is depicted that we need reduction operation, so मेरे को reduction perform करना पड़ेगा. So मैं reduction कैसे perform करूंगी? Reduction perform करने के लिए what is my irreducible polynomial? My irreducible polynomial is 1 0 0 0 1 1 0 1 0. Okay. Now how many terms are there? 1 2 3 4 5 6 7 8 9. यहाँ पे कितने टर्म है? 1 2 3 4 5 6 7 8 9. ठीक. और यहाँ पे मैं शिफ्ट लेफ्ट कर रही हूँ. कितने टर्म बचे? 1 2 3 4 5 6 7 8. Only 8 terms are there and in the irreducible polynomial we have 9 terms. तो यहाँ पे मेरे नंबर ऑफ डिजिट ज्यादा हो रहे हैं, यहाँ पे मेरे कम हो रहे हैं नंबर ऑफ डिजिट. और जो भी मुझे रिडक्शन परफॉर्म करना है वो मुझे इस वाले फेज पे करना पड़ेगा. ये आंसर जो मेरे प्रीवियस रिजल्ट से आ रहा है उस पे. ठीक है. सो मैं क्या करूंगी, जो फर्स्ट डिजिट है इन द इररेड्यूसिबल पॉलिनोमियल वी हैव टू स्किप इट. ये मैं स्किप कर दूंगी. सो यहाँ से मैं अपना सेकेंड पॉलिनोमियल लिखना स्टार्ट करूंगी. दैट इज 0 0 4 times 1 and 0 0. Perform the XOR operation. And after performing the XOR operation, whatever you have skipped the value of 1, you have to add that value in the last. So what will be your final answer? That is 0 0 1 0 0 and 1 1 1, and it will be pasted over there. Now from the analysis you can check out first there is a need of reduction or not. So here the first bit is not 1, so there is no need of reduction. Just perform the left shift operation and put the answer over there. So 0 1 0 0 1 1 1 and last में 0. So if there is a no need of reduction, then the same shift left answer will be pasted over there, like 0 1 0 0 1 1 1 and 0. If there is a need of reduction, then you have to perform the XOR with the irreducible polynomial and paste the answer over there. ठीक है. Otherwise you can direct paste shift left answer over there. अब मेरे को दोबारा shift left करना है. That is 1 0 0 1 1 0 0. ठीक. अब प्रीवियस वाले पेज में मेरे को कोई भी डिडक्शन परफॉर्म नहीं करना था क्योंकि मेरी फर्स्ट बिट क्या है? 0 है, 1 नहीं है. तो मैं डायरेक्ट ये आंसर पेस्ट कर दूंगी इधर. दैट इज 1 0 0 1 1 1 and 0 0. Now in this case you have to check there is a need of reduction or not. Yes, there is a need of reduction because the first value is 1. So in that case first you have to do left shift then perform reduction. यहाँ पे मैं लिख भी देती हूँ. इस केस में क्या करना है? First perform left shift and then perform reduction. So first do the left shift, that is 0 0 1 1 0 0 and 0, and perform the left shift operation. So left shift करने के लिए मेरे को क्या करना है? ओनली इतना पार्ट लेना है. That is 0 0 0 1 1 0 1 0 और ये वैल्यू that is 0 0 1 1 1 and 0 0. Perform the XOR 0 0 1 0 0 0 1 0. Now this extra bit जो हमने skip किया है reducible polynomial में, लास्ट में मुझे ऐड करना है. So the final answer will be this one and put the answer over there. Now check there is a need of reduction in the next step or not. No, there is no need of reduction because my first value is 0. So just perform the left shift. So 0, 1, 0, 0, 0, 1, 1, 0. Because there is no need to perform the deduction, so just paste the direct answer of the shift left. Now my x5 is also over, means all of the faces are over. Now we have to just mark out that values that are in the polynomial P1. So what was in the polynomial P1? That is x to the power 5 x square plus x, right? So मेरे को ये वाला टर्म चाहिए, ये वाला टर्म चाहिए और ये वाला टर्म चाहिए. अब इन वाले टर्म के बीच में मेरे को XOR परफॉर्म करना है, ठीक है? So what is the answer? X to the power 5 that is 0 1 1 1 0 XOR with x square. x square का आंसर कितना है? That is 0 1 0 0 1 1 1 0 and last one is x, only x. So 0 0 1 0 0 and 1 1 1. So जब आप तीनों का XOR करोगे तो आंसर क्या आएगा? That is 0 0 1 0 and 4 times of 1. So that will be your final answer and it will be same as the previous case. But in terms of the binary only. So in the exam, it can be direct asking of the question like in terms of the binary, and you have to convert it into the digit, polynomial value. Otherwise इसका उलट ये वाला भी आ सकता है, तो दोनों में कोई भी आ सकता है, तो आपको कन्वर्ट करना पड़ेगा, कन्वर्ट करके आपको दिया नहीं जाएगा. ठीक है, कहने का मतलब है कि मे भी आपको ये वाला फेज दे दिया जाए, बोला जाए कि पॉलिनोमियल टाइप वाला ऑपरेशन आपको परफॉर्म करना है, मींस यू हैव टू कन्वर्ट इट इनटू द एक्स टर्म वैल्यूज. ठीक है, दूसरी तरीके से कैसे आ सकता है कि आपको ये वाले टर्म दे दिए जाए x5 वाले और कहा जाए कि बाइनरी ऑपरेशन परफॉर्म करना है, तो उस केस में आपको इसको बाइनरी में कन्वर्ट करना पड़ेगा और तब ऑपरेशन परफॉर्म करना पड़ेगा. तो दोनों के लिए आप रेडी है ना? चलो डाउट आज तक के सेशन में थोड़ा सा मैं क्लियर आज नहीं बोल पाई, थोड़ा सा प्रॉब्लम है मेरे गले में, लेकिन फिर भी मैंने कोशिश किया है कि मैं प्रॉपर समझा पाऊँ. If you have doubt, kindly mention in the chat, otherwise you can leave the meeting.